party. We've got to turn the project in early.
Hey everyone, oh, it says class is over still. I was grabbing some lunch, relax for a moment. What should we do? Should we do the project or should we do some of the homework? I hope people are still here. Which of those two should we do? Project or homework or quiz? So we can start with the project right now, talk over some of it. What do people want to do? Quiz questions. People are saying, oh, all those quiz questions. Let's see. Which one should we do first? Name the one, a lot of quizzes. Okay, quiz question time. I guess we'll have time next week to start the project. So quiz questions it looks to be. Which ones should we do? Which ones should we do? Oh, someone said here. Which ones should we do? You name it, we'll do it here first. Quiz questions it is. Which ones should we do? In 1998, the Nabisco company announced the 1,000 chip challenge. In 1998, the summaries. Tara's got one here too. Let's get going on some questions. Put the wrong thing right there. In 1998. Okay. 233, stat 201, chapter 14, quiz. Okay, we can do Tara's first if you find hers. Yeah, well, let's see right here. Let's check this out. We'll see which one we see first. A researcher measured is the other one. 1998. Researcher measured. Ah, here it is. Researcher. Wait, that's body temperatures. Here's the flight leaving on time. What are the chances of your flight leaving on time? Okay. So this one is flight leaving on time one. So we need to change this. Okay. The flight leaving on time. How do we... The 30th. Check out the instructions. Really good stuff right there. Thank you to Terry Higgins. Doing a lot of work to get the project out. Released it on Friday. Friday. Here we go with the first question. What are your chances that a flight will leave on time? A government bureau published the information about airline performance. The accompanying histogram and summary statistics are provided for the percent of flights departing each month from January to 1994 to 2016. There is no evidence of a trend over time, so they're talking about the time series there, which we're not going to go into. The data looks kind of what to you right here? The data looks kind of what? It looks nearly this. And the sample size is very large, way over 100, so even if there is a little bit of skew, but we'd say because condition 1 is randomly collect the data, which kind of, and then great job, Tara, right there, nearly normal. Only a tiny bit of skew, a little left skew, right? But only a little. Looks nearly normal, which is condition 3 for quantitative data. So the important part of this question right here is going to be the summary statistics. So the summary statistics is the big important part of this question. And when it comes down to it, they're going to have us make the confidence interval. So condition 1 is going to be that we randomly collect the data. Woo! Condition 2, it's less than 10% of all possibilities, which less than 10% of the population, which is true. And condition 3 is going to be that it is nearly normal. So they do come from the normal. It's pretty random and independent. It could be skewed at the small sample size. Exactly. If it's a small sample size, then the skew will be a problem because the distribution of the sample mean will not be normal. 99% confidence. So let's do this right here. Let's solve the question. Confidence interval, 99%. So what is the last bit of notation we're missing right here? So we are missing one more thing, and I'll start writing the equation for this. So the equation is y bar plus or minus t star n minus 1 degrees of freedom. We need to find the t, you're right. And what else do we usually find when we find the t, which tells us the shape of the t? And great job, Tara. What else do we usually find with the t that helps us find the shape of the t? So we should probably find that. And I can probably tell you the t. The t is going to be about 2.59. That's a guess. The degrees of freedom. And how do we find degrees of freedom? N minus 1 for the one sample t. And that's what we're talking down there, n minus 1 for the one sample t. And there it is right there, 269 degrees of freedom. And so now let's go find the t right here on the t-applet. Now, the reason I was able to take a pretty good guess of this is because it's going to be pretty normal. So when there's a lot of degrees of freedom, it's going to be pretty normal. 99 p-value and 269, was it? 2.595. So my guess of 2.59 was very close. It's 2.595. And that's because I know the p-value 2.5758 for the z-score. That's because I know the z-score there, Charlie. Like the z-score for 99 is 2.5758, and the t is always a little bit wider. So my knowledge of the z-score helped me solve for the t because I know the z-score for this is 2.5758. So at it again. So since I knew that, I was able to take a guess of the t and get kind of close. So I was like, well, it's going to be a little further out, and we have a lot of freedom, so it's going to be basically normal. So any questions on how I found any of this notation? We have the sample mean. So sample mean, t statistic based on the percent confidence level, the standard deviation, and the sample size right here. There it is right there. So now that we have all this information, let's just plug in the numbers. So 78178 plus or minus 2.595, and then s of 5.012 over square root of 270. And then just be very careful solving this. It's very easy to make errors, and that's where we lose points. 270 square root 5.012 divided by, there it is right there, times 2.595, and there's that. I have just found the what. If you're following along with this problem, what have I just found right there? And I'm showing you it on the end of the plus or minus. By solving everything out right there, I have just found the what of this problem, which a question could ask you to find the margin of error. Great job, Tara, right there. Those are the margin. That is the margin of error right there, the plus or minus. So that is going to help us make the interval. And so let's go ahead and amazing work, Tara. That's the knowledge you want, to be like everything after this is the margin of error, and this is the estimate. So the margin of error is 0.7915 plus or minus. There we go. And so now let's take a look. And 78.178 plus. There we go. And let's take a look. Here we go. Can we do a researcher measured by temperature? I think, yeah, I don't know if we've done that one yet. Let's check it out. Sounds like a good one. I think someone else mentioning it. Sounds familiar. Yeah, Tara mentioned it. So yeah, let's do one next, Stone. Thank you for being here, Stone. There's the answers to the question. Chips ahoy. Chips ahoy. Yeah, we'll do some Chips ahoy too. You got it. Did Mott Pearson make a deal with Chips ahoy? Were they like, we will advertise your product in our question. 2 decimal places as needed. What's the other one? 79 point something. 78.97. Well, these come down to the notation. Could T-dot test solve this problem? Yeah, it could. Let's do that really quick. Oh, no, T-dot test takes a vector. I don't think you can enter in... I don't know why T-dot test is not showing up. There it is. It takes a vector of information, so unfortunately we couldn't do it with T-dot test because it takes the vector. And so we could make our own function to do it, but T-dot test takes a vector and default tests it against 0. And so T-dot test won't do it because this is using summary statistics. And a lot of times, that's why R doesn't have a thing to do summary statistics, because a lot of times we just solve it that way and then we would get the summary statistics. So it's quicker in programs to just like run the data. Interpret the interval. I am 99% confident the true mean, and right here, the true mean probability. Let's see here. The true mean I am 99% confident that the true mean monthly percentage of on-time flights will always fall in the interval. Sounds weird. There is 99% confidence that the probability of any given, not a given flight. There is 99% confidence that the probability of all flights departing on time. It sounds between two. I don't love their wording here. There is 99% confidence that the interval contains the true mean. Oh, wait, I should have just read the last one. There is 99% confidence the interval contains the true mean monthly percentage of on-time flights, because that's what we're trying to estimate. Yeah. So when we do this right here, remember our phrasing. I am blank percent confident that the true blank is contained in the interval blank to blank. So they don't give you the interval because I would give away the answer. Some of them have you type it a second time, but I am 99% confident that the interval contains the true mean monthly percentage of on-time flights, and the interval is blank to blank. So this is going to be the answer right here, unless I've made an error. Oh, no, it's not that one, is it? No way. Did I type the interval in? It is. We got this correct. All the conditions are met, right? Let's just unclick this. What did I do wrong on my interval? Ooh, it was this? It was this? The sample is neither... Oh. So they're saying don't do it? The sample is neither a randomized sample nor from a suitable randomized experiment. Really? Yeah, I guess the first thing I said is we should acknowledge the what of this data. Charlie, this kind of gets to it. It's the first question that's got me in a long time. They didn't assume it, right? We won't pull that game on you on the test. If you remember what was the first thing I said is we should probably look at this as a what question, which they're assuming there is no evidence of trend over time, meaning they're independent, which is part of the randomness. That is mean. If you did what I did, just let me know. I'll give you the points. Say, hey, Brian, you said you give points back on this. That the first thing you have to do in time series data is look at the time order pattern of the data. And so we teach a full class on this. And so if they assume that it's coming from a random process, that's kind of where they were going with this. Does that make sense, Charlie? Like, I thought they were going that this data comes from a random process. And if it just comes from the random normal, then it's, a random process. And so we have to think about ways to handle time series data a little bit differently. And check out this book right here, FPP3, which is an amazing book, which goes over time ordered data and looking at different patterns in data and correlation, all this good stuff. Really awesome book, totally free online. Got some correlation pairs right here with correlation matrix. But I thought that's where they were going, that we could assume that they're just kind of random and they come from the random normal there is no evidence of a trend over time. If there's no trend over time, I really thought that they were telling us, because if there's no trend, it's just random. We learned about time series data have to be in order to do analysis and jump in BS340. Yep. So this is a good question. They tricked me on that one. I really disagree with the wording. If there's no evidence of a trend, is this a stochastic process, i.e. random? My Pearson, how dare you with that one right there. We had a streak going. I was like, I did my calculations correctly. I am blank percent confident the true blanks can roll blank to blank. Yeah. That's why we get to do them live right here. I think we're going to do Chips Ahoy next. Let's do some Chips Ahoy. What is some Chips Ahoy? Chips Ahoy. Oh, wait, did people say body temperatures? Body temperature one was one we also have, and then Chips Ahoy. So a researcher measured body temperatures. Let's grab body temperatures and then Chips Ahoy. We can do body temps. This one right here. Thank you, Tara, right there. And thank you, everybody. No one's ever like, Brian doesn't know statistics. Every once in a while, we get something wrong. We were on a streak. I think last week we really didn't get any wrong. Oh, man. We had a good streak going for a while, but we'll just build back up the streak. Mubot is here in the chat, right? He's chilling out. Yeah, he's giving out some points. All right, let's do this. So a researcher measured the body temperatures of a randomly selected group of adults. Oh my gosh, do you know what that means? Whoa. Means we got the randomness. Did they take less than 10% of all adults? Watch the sample size be like 5 million Americans. Well, that would be less than 10% too. Watch the sample size be 50 million Americans. That'd be more than 10%. I think it was like 350 million Americans, 350 million. Let's take a look at the data right here. Well, there's the summary statistics. Here's the histogram. How many individuals did they get? It's pretty nearly normal, and I'll tell you why. Their sample size is 52. So if there is a little bit of skew, we need a sample size of at least what? If there's a little bit of skew in the histogram, we need a sample size of at least what? 25. So this is not heavily skewed, which you need 100 for. So we're going to say it's nearly normal by way of large enough n. So the third condition, I love this question right now on the way it's doing the conditions. Random, I wish it was first. 10%, less than 10% of the adults of the population are selected. And last but not least, nearly normal, which states that we can check it via histogram, normal quantile plot, or a goodness of fit test, or we could say by large enough n, the distribution of the mean is going to be nearly normal. And y'all, there we go. And so find a 90% confidence interval. So what is this portion of the question really going to boil down to find the 90% confidence interval? And they're giving you a lot of extra info right here. To make the 90% confidence interval, what is this question going to boil down to now? To make a 90% confidence interval, what is it going to boil down to? Here's the hint for it. Notation.
Notation, brother.
So where is y bar? What is y bar? Is the meme. Where is n? Great job, Tara. Thank you, Charlie. Good to see you, Victoria. 52. What is S? They give you extra stuff right here. They're just giving you way too much. They're like, here's a bunch of stuff you don't need. And then the T, we're going to have to go and find. What are the degrees of freedom for the T? The T is going to be about equal to 1.7. We'll go with that. Let's check out what the T is equal to. We need to go over to our T app. That's just a guess right there of what the T will be. Yeah, sure, it's close enough. I was even trying to do more exact. It's going to be pretty close to that. So let's go over here and enter in the degrees of freedom. For the T is 51 degrees of freedom. Go over here to this one and go to 90%. Oh, it's 1.68. Well, for 95, it'll be closer to 2. For 90%, so this is a 90%, 1.67 right there, 1.675. So close-ish. Close-ish. Go to the T applet. The degrees of freedom determine the shape. Oh, yours says 95? Close to 2. Good answers right there. Probably a 2.01 or so if the sample sizes are similar. You are correct. Yours should be very close to 2 for that. Mine is 1.675. Yep. 1.6. It was 2.01? I've done a lot of these. So that's got it. We've now solved the notation for this. And now we just plug in the numbers. All right, we're going to watch this mod. You ready? Hide user on channel. There you go. Boom. That's what we do. We ban people here. That's why we got mods, in case I don't see it. Standard deviation. We're on the internet. Oh, wait. Oh, yeah, so we're screwing it in. There we go. Okay. 0.6872. Yeah, it's because it's public. That's why. That's why we're on the internets. We are on the internets. Oh, blocking that. We're on the internets. 98.98. 98.98. 98.66. Explain the meaning. I am 90% confident that the true mean of body temperature is contained in the interval blank to blank. I've heard body temperatures lower than that. Like people say, I've heard we're actually around cooler than 98.6. There is 90% confident. That's a pretty small interval. Small standard deviation. Bots, boo. So only MuBot we like.
I am the only bot. All other bots are inferior to MuBot. Thank you, Victoria.
Good job, MuBot. There is 90% confident that the interval contains the... I hate their interpretations right here. There is 90% confident based on the data that the body temperature for all adults falls in the interval. They might be doing that one. The mean body temperature will always fall. I don't like the always fall. That the body temperature for all adults is in the interval. Here it is right here. The interval contains the mean body temperature. That is correct right there. The mean body temperature of adults. I wish they put that. See, it's sometimes they put a little extra context, and I hate that because they could have said the interval contains the mean body temperature for adults. So for all adults, which is the true mean. Yeah, that's where they're getting me a little scared. Yeah, well, that's what they're, because for all adults, I'm going to be really mad if they did this one, that the body temperature, and I want to explain why. So the reason I don't like that first one is it puts the active word on the mean. We don't like to say the mean falls in the interval. We like to say the mean is contained in the interval. So this is something very specific, that the interval is created to contain the truth. Falling, it sounds like the truth fell in that interval, like it just fell in there. The interval might contain it, and the interval is created. So the active word in statistics is more aptly applied to the interval containing the truth rather than the truth falling, which is an active word on the truth. So that's very specific, very pedantic, but statisticians are very careful with their words to say, I am 90% confident that the true mean temperature of body temperature for adults is contained within the interval blank to blank. That's why I always use that interpretation, but my Pearson likes to switch it up. Explain what 90% confidence means. It means 90% of 90% confidence intervals are expected to contain the truth. So let's see what conforms to that right here. 90% of all sample sizes of this size have a mean body temperature that is in the interval. No. 90% of all such random samples will produce intervals containing the true mean temperature. That's right there. A temperature of 98.6 is commonly assumed to be normal. Does this data suggest otherwise? Yes or no? 98.6 is thought to be normal. Does my data suggest otherwise? Yes or no? Great job, Tara, right there. We'll do the chip challenge here in a second. Does this data suggest otherwise for 98.6? Yes or no? Be very careful. Be very, very specific. Specific. Does this data suggest otherwise? 98.6 is thought to be the average body temperature. Does this data give evidence elsewise? So look very carefully at the interval. And does the data give evidence against that claim? Which is how you can do a hypothesis test with an interval. It does. So Charlie, what would you say you do to the idea of 98.6 with this interval using a 0.10 alpha? And that's some advanced knowledge if you're watching this. You could actually do a two-tailed hypothesis test with 1 minus confidence level alpha. So if 90% confidence is used, 0.10 alpha can be used. So what do you think? You would what the idea of 98.6? You would what the idea of 98.6? You would what the idea of 98.6? This is really good knowledge for the test. So a value that is outside your interval, you could what? If I said, do you think the average body temperature is 80 degrees, you'd be like, nah, I what that idea. Any temperature outside the interval you could what? You can reject. So we would actually, exactly, Charlie, right there, you'd reject it. You'd say, I don't believe that, I reject it. So since 98.6 is outside the interval, since the interval confidence interval does not contain it, the data suggests that a temperature of 98.6 is not plausible as the true mean. Woo! Lots of multiple parts right there. Let's do some chip challenge. So we got to do the 1,000 chip challenge. 1,000. There's the hot dog one. 1,000 chip challenge. This one's a really good one. This one requires jump. You could do it by hand, but oof, I would not. I would not do this question by hand. It's going to be a lot of work if you do this question by hand. Okay, 1,000 chip challenge. So the first thing you want to do is you want to take your data right here, copy to clipboard, and there's the vector of quantitative data. Vector just means a long line of information, like numbers put into a line, so a vector. So here we go. We're going to hit Control-C or Command-C on a Mac. We're going to get Jump on opened over here. And when you get inside a Jump, you can be anywhere inside a Jump and go to File, New, Data Table. File, New, Data Table. File, New, Data Table. I'm just going to keep repeating that. File, New, Data Table. With File, New, Data Table, you want to click Edit, and I believe Paste with Column Names. Edit, Paste with Column Names. Don't click inside of it yet. We don't want to paste with column names. Start over. You're like, no, Brian, you just wasted my time. I'm sorry. File, New Data Table, and now go to Edit, Paste. You should notice there was no column name. When we go to Edit, Paste right here, you notice the first value does not go into the column name, where if you pasted with column names, there was not a column name. So the way on the left right there is the wrong way. Just start over again, repaste the data. There is no column name. You could, if you want, double click right here and call it chips. And then you've named the vector, and that's just the name of the data. So this is the amount of chips that were in the bags. And make sure it looks like this. Make sure you have 14 observations, and you're good to go. So now when we analyze this, we're going to go here to Analyze Distribution. Analyze Distribution. Double click chips. And then click OK. Analyze Distribution, double click chips, and then click OK. Now we should see the shape of the data right here. Go ahead and click the top right arrow and click Stack to put it in horizontal layout. And now, make it a little bit bigger, make it a little more pretty. And now you can see the 95% confidence interval. If it asks for something like an 80% or 90%, you can always go here to confidence interval. Really? Oh, it's on the other side of the screen. You can always go over here. Usually does it better, to confidence interval, and then go to other, and under confidence interval other, under the red arrow, you can select a different percentage, like something like 90, and then don't make any changes. We don't know sigma. We're doing two-sided confidence intervals, and then you will get the other confidence intervals if you want them. I think it asked for a 95 though, so we already have the answer to the 95% confidence interval right here with I am 95% confident that the true mean chips per bag in the 1,000 chips challenge bags was contained in the interval 1,184 to 1,300. So that is what we think. Let's check out the question. The question says, are the assumptions met? The data need to be from a random sample, so one can assume that they are not independent. So if the data are from a random sample, they would actually be independent. That is key right there. If data is from a random sample, they are independent because we take things randomly, so they shouldn't depend on each other. It's like, let me take this bag off the shelf and this bag over here, random bags. So it's not like they came out of the factory at the same time, we would hope. And that way, if one of them got like too few chips, the other ones around it might also have too few or too many, like dependent. I think it is D, right? The data are from a random sample, so one can assume they are independent. I think so. Yeah. So it's talking about the independence. Yeah. So basically random meets it. So as long as you have randomness, which I thought we had for the other thing, great job, Victoria, right there. Yup. And so now, how did it look? Did it look more like B, C, D, or A? Let's take a look at that data again right here. Here's our data. I need to make it smaller. Which one of these did it look like? There's it right there. Might be hard to tell. Probably between, oof. Well, if you look, it starts at 1100 and goes to 1400. So which ones? Ooh, pretty tricky. Now, what you could do right here, because this is kind of tricky, I might think it's B. My best guess is B right now. So before I confirm that, or before I submit the question, I'm going to do the following. These bins right here start at 900 and go to 1600 and go by lengths of 100. If you count it out, 900, 1000, 1100, 1200, 1300, 1400, 1500, 1600. So everything here is the same. It's definitely not A. So let's go and take a look right here and do the following with our data. You can go to the number line right here and double click it. Under it, you want to change the minimum to 900 and the maximum to 1600, and it's already changed the bin widths to 100. I think it actually is using 50 increments of 100. I thought we did increments of 100, right? No, let me change my bins again. That's got it. Oh, so there it is right there. It is going to be, it is actually, if you take a look at it, that's a tricky one. It is actually going to be histogram D. So histogram D, I'm blocking it with my head right there. So it is histogram D right there. Once again, I double clicked this and then I went 900 and then I guess that's what did it. Set your settings to this right here. I did have to do an additional thing by grabbing the hand icon right here and pulling up or down on it to change bin widths. And then you notice right here, 900, 1000, 1100, 1200, 1300. And so the bin widths are identical, and this confirms that graphic is the answer. So that is what we want to see right there. Evaluate the histogram. So this is to see the nearly normal condition right here. So the histogram is unimodal and symmetric right there. Oop, why didn't we click it? And with no real outliers, that is correct. So it's got to be this. So one can assume that data comes from a population that follows the normal. And this one right here, we are using the T statistic. Now, this is where I'm a little concerned. I know this one has got me before. This one has got me, so watch out. This one has got me. We are using the T distribution here. So that's where it's scary. I always second guess myself. It is roughly unimodal and symmetric. So one can assume that data come from a population that follows a... We are using the student T model. We are checking the nearly normal condition. We'll use the T statistics. And... I am so afraid. We'll find out the answer here. Don't put in that answer yet. Because we're using the T statistic to calculate a T interval. My brain's on like 5 hours of doing stats. What's the answer to this one, Justin? What's the answer? Because now we just got to take the 95% confidence roll and say, I am 95% confident that the true mean chips in the bag is contained in the interval blank to blank. We use T statistics to calculate this. And there's the lower right there, the lower interval, put asymmetric. Yeah, not asymmetric. It's unimodal symmetric right there. 11843. And then 1303. What does the confidence rule say about Nabisco's claim? So we're talking about the mean right here. We're talking about the mean for all bags. Because the confidence rule includes, no, it doesn't include. Because the confidence rule is entirely above, the mean number of chips per bags is likely more than this. So there it is right there. However, the normal model predicts that a small amount of individual bags will have fewer than 1,000 chips. And that's if we talk about how the data is originally distributed. So let's see. I'm so afraid it's going to be there. It is. It always is. It's that one. That is it. I know it. I always second guess myself. We are using the T distribution for this, and so I'm slightly always mad at my Pearson on that one. Please, for that one right there, if you answered the reverse, what you really just need to know, it's unimodal and symmetric. But even if there is like a light outlier, like a great statistician once said to me, It's not how many conditions we violate, it's how bad we violate them. Like we're always going to have problems with conditions. So there's always going to be some condition we fail, violate, we have a problem with. And so we have to look at how bad we fail the condition, how bad we do. So how extreme is the outlier? What's the deal with the outlier? So it's not, if there was an outlier, it wouldn't be the end of the world. It would just be like, well, how much data do we have? How extreme is the outlier? How does this apply? So one can assume data comes from a population that's normal. Yeah, because I mean, the population would follow a normal, I guess, to be exact. We use the t to create the interval. So the t distribution isn't about the shape of the population. So I guess I'm actually going to take the hit on that one, because we wouldn't say, I got to put this in my brain better. We wouldn't say that the population follows a t. The t is what is used to create the interval. The population, we assume, and the condition once again is nearly normal. So it's symmetric. Why did you not say that? It is symmetric. It's roughly unimodal and symmetric. The histogram is roughly unimodal symmetric with no outliers, so when it's in the data comes from the population that follows normal. That is correct right there. And the population follows the normal. The population wouldn't follow a t. Got to put that in my brain a little bit better. So, yeah, I agree. I kind of agree with that answer now, like, as I think it over. Don't ban this question. Brian's messed up 2 questions. 2 errors. What other ones should we do? What other questions should we do? You name it, we do it. What other questions should we do? What should we do? I absolutely love using the T-Hill. I love these. These are my top favorite questions. I'm going to redeem myself on these questions right here. I'm going to redeem myself using the T-table. Using the T-table. Name the questions we shall do it. This is one of my favorite ones. Chapter 14 quiz. Now, I don't use T-tables. I use an applet. So they're smart enough to say you can use an applet, which is very much right to use. The 99% confidence is going to be the easier one to do because it has 81 degrees of freedom. So this is going to be about 2.63. That's a guess. And the 95% confidence is a lot harder. Let's see, do we get either of them right? 50%, we got one of them right. So the reason I'm able to do these is because the T is based on the Z. If I had to guess which one I got right, it's probably the lower one. There we go, now we got them both right. So how am I able to guess these? The T is based on the Z. What is the Z score for a 95% confidence interval? What is the Z score for a 95% confidence interval? Timothy, good to see you here. What is the Z score for a 95% confidence interval? Does anyone know that for 1,000 points? What is the Z score? This is a classic number in statistics. The Z score for a 95% confidence interval. What is the Z score for a 95% confidence interval? Close, Justin, close. Not quite 2. Kind of 2. Kind of 2. 1.96 to be exact, right? No. It is basically 2. Because here's what's really cool, Justin. This is a little more advanced on this. But check this out. Yeah, when they give them, it's really nice, right? So, Justin, I want you to see this. This is the more advanced stuff. I'm going to make a model, not make a car yet, that predicts the horsepower of a car from its weight. So here is regression. This is a linear regression to predict the horsepower of a car from its weight. And what important thing do you see right here that we've been covering right now? What important thing do you see that's like, wait a minute, we're doing that right now? Oh my gosh. Oh my gosh, you got to be kidding me. That's the T statistic, right? So what if I asked you to make a 95% confidence interval for the coefficient of weight? What if I told you I can do it kind of in my head? It's about 26 to 66. I gotta do it. How am I able to tell you the 95% confidence interval for the coefficient of weight and do it in my head? Well, so think about this, Justin. You said it's basically what? What is the T statistic for a 95% confidence interval? So the formula for this one, which we don't do in our class, it's basically 2, right? So what you do is you take your estimate and then you go plus or minus 2 times the standard error. That's basically a 95% confidence interval. So what is the estimate of the coefficient of weight? So what is the estimate? Just round it. Just give it to me as a rounded number. What is the estimate of the coefficient of weight? And I think you see it. You have it earlier in the chat. Oh, Justin, I see what you did right there. Justin, you're right. I just rounded up to 10. Yeah, so, and then not plus or minus, right? You did it correctly, Justin, because check this out. Because if you do plus 18, you're saying 46 plus 18, 46 minus 18, but I'd probably just round it up a little bit because it's usually going to be a little bit bigger, like especially with smaller sample sizes. So I'm saying 46 plus 2 times 10. And then I'm doing, oh, I forgot to do the times. I've been doing this for years and I always forget that. So there's the interval, and confident can give us the answers here, and there's the answer. Is it not basically 26 to 66? You just made a 95% confidence interval for the coefficient of weight. Like that. And you can find out the exact answer if you want, but you can be like, basically plus or minus 2 standard errors. That's it. It's that quick. But the program is going to do it for you. Like, you can just change your confidence level or whatever. You can go here to level equals and go to 99%, and it's going to be a bigger interval, which are the concepts we need to know. If you notice now, the interval got bigger because we went 99% confidence instead of 95% confidence. So if you're wondering how I solved these questions right here, T's are basically like Z's. Now, you have to know the degrees of freedom for the T. So we went a little bit advanced on this one. This one said we have 18 degrees of freedom. So you first enter in the degrees of freedom. Then you make sure you're set to the confidence interval 1, which is the between. And then you go right here and you enter in the percent confidence. So the percent confidence is 95 and the T statistic is 2.101. I think I got close enough in my guess. The answer should be 2.10. It did accept the answer originally, so I got close enough. The next one says 99% confidence with 81 degrees of freedom. So 99% confidence with 81 degrees of freedom would look the following way, and it's 2.88. I got that? Whoa, wait, that's a 5. I was like, there we go. 2.64. Oh, and I was right. I almost, if I'd put a 8 after this, I would have had it to the decimal, but 2.64. And the reason I'm able to guess these a lot of times is because, remember, this is basically 2, but the T will always be water to the Z. So, Justin, here's a really great thing to know about the T. The T statistic is always a little water than the Z. Could you do surveying college students? Of course. How does it give me the exact start of the question like surveying college students? The T is always what to the Z. The T is always what to the Z. Like when you find it, it's always greater than. Because William Gossett found that his intervals were not large enough, so he added in extra variation for smaller sample sizes. So when your sample size is smaller, your degrees of freedom is larger. So if you look at the 95% value, it's ridiculous to make a 95% confidence interval when your sample size is 2, because degrees of freedom n minus 1. But as your sample size increases, the T starts to converge towards the Z. And after a certain point,
It doesn't matter.
that's when people just start using the Z. And Mr. T smashed it down, and he made that interval go like this. So he made your intervals wider because smaller sample sizes need to encompass more variation that could possibly be in the data. The theory behind this, Justin, is, and anyone else listening to, is when you take a small sample, you might not get outliers, because if you sample a small bit of data, you're less likely to get outliers, and outliers greatly increase standard deviation. So William Gossett countered that by saying, like, the smaller your sample, the less likely you are to have outliers. So the smaller your sample, the more variation I'm going to allow in the distribution to kind of counterbalance that. So the T is a counterbalance to probably your inability to capture the full standard deviation of the data due to outliers that are uncommonly seen in the data. It's more likely you underestimate the variation in the data. So he included more variation in the T than is seen in the normal. So the T is more smashed down. It's a more smashed down distribution, which allows for more variation. That's the more technical reasons behind the T. The T is always larger than the Z. The T converges towards the Z as we get infinite degrees of freedom. That's why when I know a Z score, it can help me find a T score and give a guess of it. So I love taking guesses at these. I don't know. And Stone, did you put the star of the question in there? That's the same one. It doesn't change it. I'm trying to find it here. Stone said, surveying college students. Medical researcher? Uh-huh. We'll try to find both of these right here. Surveying college students. We haven't done the hot dog one yet. I need some chill. Is that medical researcher? There's pulse rates. So number 9. Oh, thank you, Shelby. Shelby, you are awesome. Did I put the points in the chat? There's some points. I'll throw another 0 on that. Shelby, thank you so much. I think so. Shelby, let me take both of these right here. I really appreciate you dropping it in there. It helps me know the start of the question, know exactly what to look for. Did the hot dog one? Yeah, they're all pretty similar when you start to see the themes of them and then what you have to examine. So that's the key, is to know the themes of the question, to know the notation. I want the college one too. The college one? Awesome. Yeah. Good. That's great. We'll do the college one first since don't ask for it. It's this one right here, right? After serving, we got it right here. Okay, here we go. Let me take the timestamp on this and we'll start it up right here. Thank you everyone for being here. And future students, I really appreciate people watching this in the future. I know people have jobs, work, kids, you name it. And so some people can't watch this live, but if you're here watching it later, we appreciate that. You're welcome, Stone. Anytime. So here we are with the question. Have you done the project? We haven't done the project. We might need to do it tomorrow. We could maybe do that like most of tomorrow. Like be like, hey, let's focus on tomorrow. That might be what we do. Good to see you here, Blake. After surveying college students, a campus organization calculated the 95% confidence interval for the mean cost of food for one item. Oh, for one term. Why'd I say item? I guess it's almost that word reconfigured if that was an I right there. Is this. That's the cost for one term? What? One term is like 120 days, right? Yeah, it's about right, maybe. I don't know. It depends. Now the organization is trying to write its report and is considering the following interpretations. Comment on each of the following. So what's the first thing you should do right here that would get you test ready? What is the first thing you should do? And I'll do it for you if you ask. It might be. A is not correct. So before, and Stone, great job right here. Stone, we're going to make you a mod right here. What is the first thing that you would do to practice for the test right now? Well, there's kind of some notation on this one. There's the lower and the upper. We could find the center of the interval. So you could find the center of the interval by doing lower plus upper divided by 2. That's the center, which is the sample mean, and the interpretation, right? So let's try interpreting. You ready? I'm going to give you the interpretation. I am 95% confident the true mean amount of money spent by students during a semester is contained in the interval $1,372 to $1,562. So what does this one say? 95% of all students pay between... We are trying to estimate the what. Don't even look at their answers. We're talking about I am 95% confident what. It's not about all students paying that. We're trying to estimate the what with the interval, the mean, the true mean. So let's see if one of those kind of says that. This interpretation is incorrect. The confidence interval is about, the confidence interval estimates, no. And confidence interval is not about individuals in the population. Can you go over this one? I think we did that one earlier. Yes, that is in the first part. That's the first 3 minutes, very start of this video. Check that out and tell me if you have any questions, Reagan. That is at the very start of this video. If you can actually rewind in time, that's at the very start of this video. Check it out. We might circle back to that, but thank you, Reagan, for asking. Which problem did whatever the winter problem? I don't know if we did. Oh, no, sorry. You only know by asking. I don't think we did the winter one yet, Justin. So put that one in the chat too. Next one says 95% of the sampled students. No. This is an interval to estimate the truth. The sample is going to have, no, it's just, no. The interval, the interpretation is incorrect. A confidence interval is not about the individuals. That is, yeah, that might be right. A confidence interval is not about, no, it is about a population parameter. So that's just wrong. A confidence interval is about it. So that's a wrong statement. It's not correct. This isn't incorrect. One knows that, no, we don't know all the sample landed between that. And truthfully, I could tell you we know they didn't because the interval is going to be tighter than the data. So the interpretation is incorrect. A confidence interval is not about the individuals in the population. They're really hammering that one home right there. One is 95% sure that students in the sample averaged between... That's not how we interpret the interval. We do know what the sample mean is. Yeah, and they actually said it right here. Remember, how do we find the mean of the interval? How would you find the mean of the interval again, which they give over there? How would you find the mean of the interval, which is the center of the interval? So go ahead and try to find the center of the interval, which is what? We did this earlier today. How do we find the center of an interval? How do we find the center? The formula for the center is what? Mathematically, the formula for the center, if you have a lower, so if it's like 60 to 70, and this is for the proportion we were doing, 60 to 70, well, the center of the interval is what? How do we find the center of an interval? The center of the interval is the what of the upper and the lower. So here's the formula, but just think of it's the what, because there's two numbers. It's the average, right? So if you average 60 and 70, which is to add them up and divide by 2, so they're getting at that here with this question, we know what the average student spent, because that's the center of the interval. So if you add them up and divide by 2, oh, if you delete your numbers, it doesn't work. That is the center. The mean cost for students in the sample is known to be this, because that's the center of the interval. That's a really good complex question right there. That's a very tough one. Like to know that you can find that via the upper and lower of the interval. Not correct. A confidence interval estimates the standard. Which one right there, Stone? This confidence interval is trying to estimate the what. So good answer, Stone, right there, and good practice. Stone, we're throwing you 1,000 points for everyone right here. This confidence interval is trying to estimate the what. Different confidence intervals try to estimate different things. This confidence interval is trying to estimate what? The true mean amount of money spent for students. So this one's trying to estimate the true mean. You could try to, there are intervals that do that, but that's not our interval today. 95% of all sample students, no. Oh my gosh, they're really hitting you with a lot of wrong interpretations. 95% of all sample students will have an average cost of food between no. The interval is incorrect, and this is wrong too. A confidence interval estimates a sample parameter. No, this is a confidence interval estimates a population parameter. We don't say sample parameters, SSPP, sample statistics, population parameters. This is just a wrong configuration of words right there. One knows that all samples will have an average. No, we don't know what the samples of students will show. The interpretation is incorrect. 95% of all samples will have an average food cost within 2 standard deviations of the true population mean. Let me see. I'm a little worried now. 95% of all samples of students. No. This one's a bit weird. The interpretation is incorrect. 95% of all samples will have an average food cost within 2 standard deviations of the true population mean. I could be very pedantic over this. Whoever wrote this question, I'm not happy with this part of it. One knows that all samples will have, no. A confidence interval, no, that's wrong there. A confidence interval, this is a true statement. That's where I'm a little worried, because this is true. Like a confidence interval, they are tricky. They're very specific on the wording. And I'm only worried about this one right here because this is a true statement. A confidence interval estimates a population parameter. That is true. 95% of all sample students, see, but that's not a population parameter, will have an average food cost. So I'm pretty sure they're going for this one. That is a bit weird, and I can be very pedantic about 2 standard deviations is not how it works. It's 1.96 with z-scores, or t's are very similar. I am 95% confident that the average amount of money paid by all students is contained in the interval blank to blank. What do you think right here? And what do I keep saying about this? A confidence interval estimates a population parameter. I am 95% confident that the true sounds good to me right there too. Did we get it? Woo! Have no fear. Have no fear. There was a few I was worried about, but like, because they say some things that are true, so you have to watch out though. It's some of them don't align with what they're saying. It's a tricky one. I know I've basically shown the answers to this, but do go over medical researcher. Ah, yes. I think we have the one next, do we? Yes, I do. So do know the wordings on these. What do confidence intervals try to estimate? Confidence intervals try to estimate what? So what do confidence intervals try to estimate? What do confidence intervals try to estimate, which they use over here? A confidence interval is always trying to estimate a what? Which wasn't the answer here, because this was just a not right saying, because 95% of all samples. No, usually, well, this is why the first thing I had people do before we did this is I said, do this. What did I say before we even started solving this? population's true mean or proportion. The true mean, the true proportion for the population, the true difference between means. So before we even did this question, I said, do what? I said, write your interpretation. I am 95% confident the true mean amount of money spent by students during a semester is contained in the interval blank to blank. And so interpret it yourself to avoid confusion to see if they're in line with that. So this one right here, I am 95% confident that the true mean amount of money paid by students over the course of the semester is contained in the interval this to this. Very close to it. I'm more specific than this one right here. I am 95% confident, and that doesn't even say anything about the truth. So that's a problem right there. This answer, I'm not a huge fan of. Once again, this one can be eliminated because a confidence interval doesn't estimate a sample parameter. That's just nonsense. One knows that all samples, we don't know that. That's saying like all the observations would be contained in there. No, that's incorrect also. So once again, write out your interpretations. That's going to be a huge help to practice for the test. Let's do that in medical researcher 1. Tricky questions. A medical researcher. Woo! Okay. A medical researcher measured the pulse rates, beats per minute of a sample. Oh, wait, I got to take the timestamp. Random. Here we go. Timestamp away. Chapter 14 quiz. There we go. So a medical researcher, random timestamp. So me about loving the randomness. Explain carefully what the interval means. Interpret. I want someone to do it in the chat because remember we're measuring pulse rates of adults. So I want you to do it in the chat right here. Practice it. Who can do it? This is good. Don't even look at it. Don't look at those. Don't look at those. You got to practice it. You got to remember how to say it before looking at their answers. So who can write it here for 10,000 points in the chat? This is where you get the real practice. If you're at home right now, say it out loud with me. I'll be saying it here in a moment. Your roommates will think you're crazy. Your parents will think you're crazy, but that's all right. We're here to learn statistics, so maybe we are a little bit crazy. So with that, try saying it. Try writing it down. You're going to learn different ways from me saying it. So if I say it, you hear it. But if you say it, you have to create the pathways in your mind to remember how to say it. If you write it down, you have to think what you're writing, which you're going to be writing it on the test. So don't even look at their answers yet, because we should be able to interpret that interval on our own. We'll give it another. This is worth 10,000 points. Who can interpret that interval? I am blank % confident that the true blank. Blake's got right here. Let's see what Blake got. I'm going to throw you blank. 10,000 points right there, Blake. I am 90% confident that the true mean of pulse rates for Vidal's is perfect. Perfect, Blake. Right there. Great job. And I think Shelby has it rounded too, that the true mean of pulse rates is, yeah. And Shelby, I'd give you 4 out of 4 on that. If you said the grader is like, you didn't put 4 adults, I'd be like,
It doesn't matter.
I'd be like, that's close enough. That's excellent work there, Shelby. Let's throw another 10,000 points. Shelby, great work right there. Blake crushing it on those points. Keep it up. So we need to know how to do this. So which of these looks similar? A, B, C, or D? We are 95. I think one of you Blake right there. We are 95% confident that the interval blank contains the true mean heart rate. Do you see how it's very similar? They just mixed up the wording a little bit. I am 95% confident that the true mean pulse rate of heart is contained in the interval blank to blank. So it's just, they switched the order of the way I traditionally do it. So if you're like, well, they're still saying how confident they are. They're still giving the parameter. They're trying to measure the true mean heart rate, and they're still giving the interval. Boom, right there. Yeah, Blake's got that down. Get to that test. Know that confidence interval interpretation. And for those who didn't know it, check it out from class today. Know how to interpret a hypothesis test. We worked on this a lot today, and then the understanding of what it means will help you solve a lot of the questions. This one is a little bit harder, right? And we'll practice a lot. A lot of the remainder of semester is knowing how to do a hypothesis test, knowing how to interpret the results. We're going to do it a lot. That's why we only have, 3 more classes? Wow. Yep. Do we have 3 or 4? I think we have 3. How do we find margin of error? Margin of error is defined as what? Because we just did 15 days, 60, 70, 90. Margin of error is defined as the what? Yep, we did body temperature. I'll show you the timestamp here if you want to find it, Blake. Margin of error is what? It's the second problem we did today. Well, that is the mathematics for it. Correct, Shelby. Good work. Shelby, great answers right there. And then Blake's showing the, that's right, 7,000 points. So yes, everyone is correct and great work. The margin of error is for this interval. I am very impressed. People throwing the math equation in there. I love seeing so many people being like, oh, for the t interval, it's t star n minus 1 degrees of freedom s over square root of n. That's so quick right there. That's amazing. And so when you look at an interval, the y bar is at the center, and then the upper is up here, and the lower is down here. And visually speaking, the margin of error is what? The length of the interval. Visually speaking, the margin of error is half the length of the interval. Now I'm going to make the problem a bit easier. This is just to estimate. My gosh. This is to make the problem easier to estimate. So tell me if it were to be that heart rate were to go to 67 to 71. So don't use the full numbers. I'm just pretending right here for a moment that it's 67 to 71. What is the margin of error? We're just using pretend numbers to make our life easier to see how the math works. 67 to 71. What is the margin of error? So Shelby, I see what you're thinking of. Good answer, Shelby. What did Shelby find? Shelby, good answers right there. Oh, but wait, Shelby, what are you finding right there? You found something. What did you just find? Is that the margin of error? Blake's got the margin of error. You found y bar. You found the sample mean, right? Great work, Shelby. So you found the sample mean. Does that make sense? And then you could describe this interval as what? How could you describe the interval now? 69. How would we talk about the interval? Well, how would we describe it? Blake's got it right there. 69 plus or minus 2. Does that make sense? Does that, like, the more you see it, the more you practice it, the more you're like, okay, it's just the center of the interval, which you found. That's the average of the two numbers. And then the margin of error is the plus or minus. So hopefully seeing this right here, like if I tell you, let's go get a really super, my wife and I are going to go get like a really fancy dinner tonight. And maybe we'll, I don't know. And it's going to cost somewhere between $160 to $200. I mean, it's going to be like, whoo, just like SpongeBob right there with Sandy. We're just going to like, so how much does Brian estimate the dinner will cost? How much does Brian estimate the dinner will cost? Do it for the anniversary, you know, for our 1 year or something. We'll do something crazy. I don't usually go out and eat dinners like this. Oh, Justin, let me know which ones you got wrong. Justin, that's really, these are tougher quizzes. These are tougher. Justin, great work. Justin, great work, man. This is tougher stuff. You're doing the real statistics right now. This is the end of the course where people just say, I have no idea. Justin, people are probably watching this right now. They're like, if I got a 92, I would just be like, party time. So great work. Congratulations, Justin. You got this. More practice. Just remember, like, you just want to practice it. Hey, if you shoot for those hundreds, you get them, great. If you get upper 90s, lower 90s, that's still awesome. So how much do we estimate the dinner will cost? One does get dropped for each section. Good answers there, Shelby. How much does Brian estimate the dinner will cost? So look at the interval, between $160 to $200. We're going really fancy right here. Going really 180, right? Did you actually do any equations or did you just look at it? Did you write down any mathematics to do this? Or did you just kind of look at it and go, because you looked at it, right? So the actual mathematics to do this is upper plus lower divided by 2. And so you would take 160 plus 200 divided by 2, and you get 180. So that's what you would actually do if you had to do it. Whipped out the TI-84. I had to do some extreme calculations. Then what's the margin of error of this interval? And once again, you can calculate this one. I miss median, ascending. Justin. Dang it. You got this, Justin. Just do it. I think you'll get 100 if you do it again, Justin. I got faith in you, man. You just guessed the interval? Put it into jump, Justin. You can put it into jump and then go analyze distribution. The jump ones are free gifts because you can just go analyze distribution and it'll tell you the answer right there. It'll tell you the interval. It'll you crack me, you kill me, Justin. Crack me up. Plus or minus 20, and that's half the length of the interval. So once again, we are creating a memory in our minds right now to remember that the margin of error is half the length of the interval. The margin of error is half the length of the interval. To get the length of the interval, take the upper, and all these decimals are insane. Take the upper minus the lower. Divide by 2. Half the length of the interval. Round to 1 decimal. And really? It's what? Do you remember when we first did this 67 to 71? You're welcome, Justin. Round to 1 decimal. What's the answer to this? Remember when we said 67 to 71? We could have just done it that way. Remember we were like, oh, 67 to 71. That's a distance of 4. Half that distance is 2, plus or minus. And if we round to 1 decimal, we could just looked at it. If they had calculated a 90% confidence roll, they were at 95. Yours wasn't. Just make sure to do upper minus lower divided by 2. When I first looked for margin of error, I did the upper. Oh, yeah, that's the middle. That's the middle of the interval, yes. Yours weren't as pretty as mine. It got some nice numbers. So here's what I want you to do to memorize this. To memorize what happens when we go from 95 to 90, I want you to hold your hands out. If I say 95 and then I say 90, I should move my hands out or in. So if I'm at 95 right now and then I say 90, should I move my hands out or in? Wait, 95 to 90. We're going at 95 and then we're going to go to 90 in because we're going to cover less area. So the interval is going to get smaller. Does that make sense? It's good to just kind of think about it. And if you're like, okay, wait, yeah, if it was 90 to 95, 90 to 95 is going to get wider. You're going to cover more area, more values, be more confident. Does that make sense? A more confident interval. It has more purple right there. Great job, Shelby, right there. And so if you're more confident, you cover more values and you make a wider interval. Oh, hey, good to see you, Ravana. Good to see you. Oh, yep, we're live. We're just chilling out right here. So, yep, you caught a live video. This is a we planned this out perfectly to perfectly say your name at that moment, to have Blake already say that in the chat. This is completely a replay right now. This was filmed 5 years ago. Tell anything happened of major importance in the last 5 years? Any big world events? Anything? Any wars? Any craziness? I don't know. You tell me. If the researcher had calculated a 90% confidence interval, the margin of error would be smaller. Woo! Which one did we have next? We got another one we're going to do. We were just talking about that theoretically. Sophomore Blake. So here's the ones we've done today. We might have a little bit time for a little bit more. Got started a little bit late. 5 years ago seems so recent. Does to me. I mean, that'd be 2017. What was I doing in 2017? I just got... No. Speed run on the next question. Which one's the next question? Which one do you want a speed run of? Let's do a speed run. We'll see how quickly we can do it. I like speed runs. Justin, thank you. That's where I have some fun. Like, I have fun solving problems too. I was just learning to drive 5 years ago. I learned to drive 25 years ago. Oh my gosh. The 10th gen. Yeah, I might. The 11th, not the 11th. The 10th, I should get the 10th gen. I seriously consider those, Blake. Yeah, just tell me I was 14 sitting in my sophomore classes. Nice. I should say way better at driving with 5 years of practice. I should be way better. They say like 99% of people think they're better than 50% of people on the road. Shelby, shout outs to you. You're welcome, Victoria. Shout outs to Shelby, because most people overestimate their driving abilities. They're like, I'm the best driver on the road. And then they're swerving all over the place. They're cutting people off, speeding, tailing. Tailing, to me, is the worst idea ever. Tailing is like the number one way to cause accidents. Like, don't tail people. Like, I'm not saying speed, but if you have the option to speed, do that over tailing. But also, don't text and drive. Like, that is like, don't text and drive, don't stream and drive, don't tweet and drive. Put your phone up while driving. I've been less than perfect. But a person very important in my life said to me, you need to put your phone up when you drive. And I do. I decided that I put my phone, I put it away. Not gonna be playing with it. So, you know, I do have a car phone. I think it's all right to talk to people over, my car phone does the broadcast thing. So it's just like talking to someone, you know, like, because it's just like accept call. But I'm not going to be punching in numbers. I can just be like, call so-and-so, you know, so don't be manipulating your phone while driving. So, but yeah, please don't text and drive. Yeah, exactly. Especially for long drives, because my mom used to get worried when I would talk to her on the phone while driving. She'd be like, you're driving a car, you should focus. And I'm like, I'm doing like a 10-hour drive. Like, I need to stimulate my mind. Like, I'm on a long road that's like 50 miles with no stops. Like, it's just in the middle of the night, like 10 p.m. or something. It's like, I need something. Exactly. It's so much easier. Like, you're just watching the road and driving, and like, you're, yeah. It's like you have a radio on or something. Like, yeah. But do not pull your phone out and start booping on it. No, I see too much of that. It's scary. I like look over and someone's starting to come in my lane and like they got their phone out and they're like, I'm like, what are you doing? You're gonna knock into my car. Actually, for bad weather, because it's like a Shelby, that's awesome. I got to drive to Michigan Tuesday by myself. Wish me a lot. Good luck, Justin, and be safe. Be safe. You know, if you need a pull over, get a hotel or something. Always remember that it's best to, you know, especially understand yourself, you know, get some good sleep, have some food, take stops when you need them. I've driven to Texas twice, and I've driven it twice just full drive nonstop. And it was a lot. Like, it's like a 13-14 hour drive one way. I left Knoxville at like 9 a.m. Man, my sister came and saw me, which was really nice. So I left Knoxville at 9 a.m. and I got to Texas at like, even though it's like 14 hours, I had to stop a few times. I think I got to Texas at 3 a.m. So I was like 16, 17 hours. Do you see wild horses? We have some palm trees down here. I haven't seen a single wild horse. It's just like I'm not in that area, I guess. There might be. We're South Texas, so maybe we're just chilling out right here. Did anyone have another? Which one did you want me to speed run, Justin? We're just chilling out for a moment. We'll probably end off here in a little bit. No, we don't have wild horses. I might have saw more wild horses up in upstate New York, maybe in the Adirondacks. I don't know if they have wild horses up there. But I like chilling. Happy holiday season, everyone. I bought a video game last night. I bought Demon Souls because I just beat Elden Ring. And I was going to do a second playthrough of Elden Ring. And I was like, this is a no-death playthrough. And I was like destroying the bosses, the earlier bosses. I was like, ha! Like, there's like a boss at the very start that's meant to basically beat you the first time. You're like, oh no. If you played Elden, no spoilers, Elden Ring spoilers, but I just destroyed that boss because I was like OP. And then I beat that, did I get to the grafted guy? I beat like a few. I was just like charging through. I was just like running through castles. To the night. I was just straight up. I was just on my horse, just like. You just like speed runs. Which one are you on right now on the quiz? Tell me which one you're on. I'll speed run that question while you're doing it. You can compete with me. Get that PLP50 right there. 10-hour drive would be so much easier enjoying the PLP50. I don't know. It's too small of a car for me. I really like. You said the 10th gen Accords, right? 10th gen Honda Accord. Buy one. Did you say Civic or Accord? You said Accord, right? $25,000. Those don't have the theft problem, do they? Nice car. One's got the leather interior. It's probably the Honda Accord 2021 LX now starts at $25,000. Just sell my car. Go to a dealership and be like, so my car got hit. Which one do you want to do, Dustin? We can do it. My car got hit in the parking lot. Honda Accord Sport T. What does the LX mean again? It's like luxury edition or something. Why should I go Sport instead of LX, Blake? Give me the details on this. Why should I go Sport versus LX? Convince me of that. Okay. Why should I go Sport versus LX? LX is the base. Oh, it's the base model? I thought it was like the luxury edition. That's the base. Interesting. Didn't know that. I don't know who's is the 2021 Honda Accord T.1 better sports sedan than the Touring is nicest? What does Touring mean? What is Touring? That is nice right there. For 40K? That is, yeah. This is the Sport right here. Looks like it's a good.
It's not on the dash. That's actually this label that's on the windshield. So
yeah, it's a shadow. Looks pretty good. This is the 2.0. Is it not the 2.0T? It says 2.0T right there. Which is an engine. This looks pretty good.
You're going to notice a big difference, especially when you go on throttle.
I feel like sometimes they make the windshields really slanted these days. Maybe it's the camera angle. Gotta go. Have fun right there. We'll probably end off here in a second. Blake and I are talking about cars. Blake's gonna turn me into a car guy. Blake's gonna have me be like, I gotta get that new Honda Accord. Gotta get it. Wasn't there a theft problem with Honda Accords, Blake? Or like Kias or something like that and other things? Oh, it's got USB ports? Of course it does, right? It's a car in the last 5 years. Of course it has USB ports. I don't know why they don't. I guess they want to keep it simple with the turn dials. Maybe those are less likely to malfunction. Like I would think everything here would be on the touch screen, which is pretty nice. So the Accord comes in 1.5T, which is the 192 horsepower, 192 pound front torque. You told me what torque was last time. I gotta try to remember these things. 2.0T is 252 horsepower and 273 pounds of front torque. Is that like the pull? What is torque again? Is it the front, like the torque is like the ability to pull? Like when you say something has this much torque, offer differences include sunroof, keyless entry, remote start, and other things. So, well, like, what is torque and why do you need torque? Like, torque is like pulling capacity, pound-feet of torque. But what is torque? So it's measured in pound-feet of torque. So, like, why is more torque better, and how much torque do you need? And what does torque do? Like, I gotta, it's like if you want to pull a boat, you need torque, right? A car that has a lot of torque gets off the line. Tell me how much torque I need when I'm at a red light so that people don't get mad at me. That is, you probably need more like you need like a V6. My dad always talks about, oh, the van has a V6 so it can pull the boat. So that's, my dad's like, oh, that we're not gonna be able to pull the van in the such and such. It's only got a V4. I mean, pull the boat. My dad, I gotta give shouts to my dad, who's a car guy, a woodworking guy. You know, you can be whatever kind of guy you want. I'm a video game guy. I'm an anime guy. I'm a statistics guy. He and I are both statistics guys. It's weird because my dad of his brothers is the only guy that does that kind of stuff. But my dad can maneuver a boat behind a car like you've never seen. Like, you know how, like, have you ever like had a boat like where you're pulling it behind a car and you have to like maybe put the boat into a garage? Like when you turn your car this way, the boat starts to go like inwards towards the car. Like you need to like maneuver it, and the way you turn is also going to turn the boat in kind of a opposite direction, it seems at times. And so my dad would have us, you know, kids, especially when we're learning how to drive, like do these things. What's up, Kenneth? Canvas content, margin of error, given the confidence roll and level of confidence. What is it? Put the direct question. We'll do it here next. You got it, Kenneth. Let's knock down. Let's do it. It's probably half the length of the margin of error. We'll see which one it is. Drop the direct question. We'll do it here. But my dad can like maneuver a boat like you've never seen. Like you're like, put the boat in the garage, and he's just like, "Roar," just like he'll put it in at like 20 miles per hour, just like, "Roar." You're just like, how'd you do that? So how do we find the margin of error on that, Kenneth? So it gives you the confidence level. The margin of error is always what? The margin of error is always what of the interval? The margin of error is always what of the interval? Your answer is going to be close to about 6 point something, I think. How do we find the margin of error? So they've given you the upper and the lower. You might have one of those ones you go, oh, I know how to do that. How do you find the margin of error? Mm-hmm. Oh, Blake's got it in the chat. Does that make sense? Your dad also does that? Like, can just see like, oh, I got to put the boat in the garage. Just like, you're like, how do you do that? How do you reverse drive? Our house in Kingsport had the best driveway ever, which apparently the people who owned it now, like, what did they do? They did something like put the driveway in the front of the house. I don't even understand how. Because the driveway looped around. So like, we would have people come over, and like, I remember I had to help one person get their car out of the driveway because you had to reverse up the driveway. It was such a good practice at going in reverse, and it's just fun practice. Yeah. So you want to take, do you see it on the screen, Kenneth? Tell me whatever you're stuck on. You want to take here, I'll show it right here. You want to take the upper minus the lower. So this is the larger number minus the lower number. And that'll give you how far those numbers are away, and then divide them by 2. So when you look at your interval right there, it's about 13 different. Yeah, is that making sense? It's half the length of the interval. So this interval up here is 160 to 200. Here, wait, this is the check. Here, can I see if you understand this? You ready? We're going to go get a steak, and the steak is going to cost somewhere between $30 to $42. Going to be a good steak. So what is the margin of error of this interval? The steak is going to cost somewhere between $30 to $42. So you can do the mathematics right here, or you can kind of look at it and be like, oh, it's going to be plus or minus this. 6, yep. Mm-hmm. And what is the mean, like the guess of how much, what is the estimate of how much the steak will cost? The estimate of how much the steak will cost is what? Yeah, once you see it a few times and you start working with it, you're like, okay, that makes sense. The margin of error is half the length of the interval. And then the estimate of how much the steak will cost is what? It's easier to talk about 36, yep. And then express the interval as a estimate plus or minus the standard, plus or minus the margin of error. So all intervals can be set to be an estimate plus or minus the margin of error. So 36 is the estimate of what we think the steak will cost, plus or minus 6. And so we've now re-expressed it. So try doing that with your interval to say, like, you could find the center if you want. The center is the estimate of the interval for when we try to estimate the true mean. The best guess is the sample mean. Yeah, no, because the 95% isn't even used in this question, because that could help us find the direct T right here. Kenneth, I've had some of my best students, I mentioned this a lot, when we're taking a test, be like, wait, where's the standard deviation? What's the sample size? How can I get margin of error without that information? Because that's the margin of error right there. The T star n minus 1, n minus 1 degrees of freedom, S over square root of n. They're like, I can't find it. And then I'm like, well, what's the margin of error? And they're like, that formula. And I say, well, what is it theoretically? And they're like, it's part of an interval. I think I got one student to say it's the plus or minus. And I say, okay. I can, whenever I help students with tests, especially in person, I can't tell you anything you don't already know. So I can't explain how to work a problem, but I could just ask you questions like, what is the margin of error? And then you could say this, and I can't say yes or no, really. I can just be like, okay. And so how do we use that? Or like, how does that create the interval? Like, yeah. Cars right here, vehicle data. Great work. There's one in Texas. Oh my gosh. 35,000. It's a good price, is it? 35,000. It's a beautiful car. It's nice white. Might be called Pearl. Used to have a car that was is it Pearl? Is that the color? Platinum white Pearl. I know some Honda Accord colors right there. Pearl. Right there. 35 is a bit hot for you. It's pretty high. Yeah. Why? Oh, it's a 2022. Well, how much does a new one cost, Blake? Yeah, Ivana, go ahead and ask, and we'll finish off with that here. How much does a new one cost? Why don't I just go buy one new from a dealership and say, here, I'll pay you cash. Here's $35,000. Give me the car. Why don't I just go buy one new? Say, go give me a new one. Why buy used? Like, or is new one gonna be like 50,000? Oh, they're super hard to find, so it's scarcity, and then the dealership's gonna be like, oh, yeah. I would just say, here's the MSRP, and that's what I'm paying. If you don't want it, I'll go to, and then they'll probably say, we'll just sell it to someone else. They wanted a 7K markup. Why? Stupid laws in America where you can't sell. I should just be able to walk up to the Honda factory and be like, hey, I want to buy a car. And they say, okay, here's your car. I say, thank you. I'm pretty sure there's laws in our country that say you can't just sell a car. It was in Knoxville too. Knoxville! It's just, I mean, why not? Why can't I just walk over and buy a car? Ivana says, for the one sample T, we only need to pick one quantitative interval. One sample T right here. Let's take a look. Ivana, thank you so much. We'll add this in right here. We had some fun. Talk some cars. Thank you, Blake. And Kenneth right here chilling out. And Ivana, thank you so much. People are going to be like, yes, project help. Stat 201, project help. One sample T. The mean. Wait, oh yeah, the interpretations. You don't want to do bad interpretations. The blue sport is hard to find. Ooh, can we do question 5 on which one? Which question 5, Kin, right there? Let me know which one, and we'll maybe check it out. We're running low on time, but we might have enough time. Good to see you, Roshni. We had a little car talk. Oh, you want to get done early? We'll probably. I think I'll spend pretty much all tomorrow doing the project about the Michelin. I think we did that one earlier today. Check it out right here, and then we're gonna do this one. If you're looking for the Michelin one, how does it start? Because I think it's right there in 1882. So check out earlier today. We did that one at 48:23 in the earlier today video. So check out morning office hours, and you will see it marked. I've already added the timestamp to morning office hours right there. Check it out. Thank you so much for that one, because we'll probably be ending here in just a little bit. So with this right here, pick a quantitative variable you are interested in analyzing. Okay. So we need to pick a quantitative variable we're interested in analyzing. Create a histogram. So you know what the first thing I would do? If I am working on my project right here, the very first thing I would do is I would say, this is the quantitative variable I am interested in analyzing and why. Does that make sense, Ivana, right there? I would say, this is the quantitative variable I'm interested in analyzing and why. Does that make sense? Pick a quantitative variable you're interested in analyzing. I don't want to say too much. I'm too afraid if I say too much, people might write the same things I say. But I'm literally going to state the variable I want to analyze, and I'm going to state why. So, boom. How are we doing on that, Ivana? Pick your variable, any variable, but it has to be quantitative. And how do you know things are quantitative in jump? How do you know things are quantitative in jump? How would you be able to be like, well, which ones of these are quantitative? How would you be able to know? I think I'm using a data set you're not using. Really? There we go. Blue. I'm blue. Ba-da-dee-da-da-da, ba-da-da-dee-da-da. That's quantitative right there. So if they're blue, they're quantitative. If they're red, they're categorical. So make sure you pick a blue one like weekly text. So make sure you pick a blue one and explain why you want to analyze it. Create a histogram and make sure it has account access, is in horizontal layout, include a screenshot of the visualization, and include the summary statistics with the quantiles section. I think I'm using a data set you can't use. Let me make sure. I'm going to make sure I am using a data set you don't use. So that way I can do a lot of work right here. Step 1 project. Oh, is it the same data set? If it is, I'm going to have to do a different one. Oh, good. Here is your data set. Yeah, it's a different one. Good. That's a different student data set. Yeah, well, we're doing part of it right now, Blake. We are doing part of it right now. We are talking through it right now. So for this, I'm going to say, I want to understand how long students are staying awake, because I think students are overworked. Does that make sense? All these darn projects. So I have done what right there, Blake? What have I just done? What did I just do? I want to understand how long students have been awake, and I want to analyze that because I think students are staying awake a lot, doing a lot of work. I have what? What did I just meet for writing my report? Like, I don't want to analyze this. I chose my quantitative variable right there. Now I've got to create the histogram, put a count access, horizontal layout, and include the quantiles and other data. So we go back to our data. We've got it clicked. You can click it right here if you want. It's a good way to find the variable. Then go to Analyze, Distribution, Double, or you can actually click the Y columns. As long as you have it clicked, the reason I clicked it is because it's already selected. If it's selected over here, you can actually just click Y columns now, and it makes it nice and easy to just find it. You can also search in this if you want to find your variable. Lots of options to find what you're looking for. Just make sure you have the Y variable of interest, and make sure it's what color, Blake, for 10,000 points. Make sure it is what? Make sure it is what color? Make sure, because that means it's quantitative. Make sure it's blue. So now that we have the blue quantitative variable here, we go ahead and click OK. Now, the first thing you want to do is click the stack, the best color. Click stack right here, actually puts it in horizontal layout. There is a horizontal layout option. I prefer to click stack. It puts it in horizontal layout. So now it's in horizontal layout. I also like to adjust this a little bit right here to make it look more pretty. And so now we are getting a more adjusted layout. You could go right here and change this if you want to say histogram of longest hours awake. You don't have to do these things, just makes it look more pretty. And you could say ma data by Brant Stevens. Spell your name correctly though if you do that. It's whatever you want. I think a lot of people don't know that you can actually edit those titles. That's not required. What is required is the horizontal layout. Also, we need to do a count access. Go right here, click the histogram options, and go to count access. I'll pause on this screen. It's the second red arrow. You need to click the second red arrow, go to histogram options, and then count access, and that'll insert a count access. As you can see, a lot of students have had a longest hours awake closer to like 25, 30. That's where the median is at. The median's at 28. The interquartiles are at 24 to 40, the 25th to 75th percentile. So that is the data. There's some outliers here. People saying they've been away for 150 hours. That is, think of days-wise, that is like 6 days. Someone has been awake for 6.25 days. I'm calling that a lie. Maybe, I don't know. Maybe they're in the Guinness Book of World Records. Don't stay awake that long. It can do weird things to your body. Like, not good things. Create a histogram. Make sure it has a count access and is in horizontal layout. Include a screenshot. So now that we have this, we definitely need to screenshot it. My preferred method of screenshot is with snipping tool or Command-Shift-4. Make sure to take a nice and pretty screenshot. If you get a little bit extra, like let's say you did this right here, when you bring it over to your Word document to write your report, make sure to remove extra components. Now, it's better to get a little bit more than to get a little bit less. But still, it never hurts to go to picture format in Word and go to the crop option. Now, when you're under crop, you can just bring in the sides a little bit here. That's picture format, crop option, and just grab a little carefully right here, pull in on the sides, and get it exactly to where you want it. You don't have to be perfect, but, you know, not too hard to make it look a lot better. You could even, if you want, add on some effects, like a little bit of a, I like that. That's a little, makes it pop a little bit right there. You know, a little nice presentation of data. Last but not least, and this is all the accoutrements. Well, I wouldn't do that. You can do some extra stuff. We could really go overboard, but, you know, making your report look a good bit better, and it depends on what a company wants, how they want things to look, but it gives a little depth to the report, so I kind of like those things. Here, wait. Wait. Hey, Mom, you're talking to my Stat 201 students.
You what, honey?
You're live on YouTube. Is that okay?
Oh yeah, I was going to congratulate
I
you on your win.
know. I was gonna say who beat you?
4 points.
Ah, my mom and I are playing what's it called?
Word chums.
Word chums. Mother Stevens on the phone right here. You want to say hey to the students, Mom? They're working on their project.
Hi students. He beat me by 4 points.
But you destroyed me the last game with like what 600 points something?
Yeah, I did really well. And this time I almost had you. I was going to come back with a 15-point word.
I had 4 letters left, and I said I have to end this game. It took me about 30 minutes. I was like, well,
I had one. I had one ready for you. Okay, I'm gonna let you scoot, honey. Love you.
Love you too, Mom. Bye. Yeah, we play question for what I should have asked you super quick. Sorry. But yeah, how did you raise? Oh, that's so kind. Thank you, Blake. Right there. She's a teacher. She was a teacher. So my mom's teacher. But we play the word basically Scrabble together via the phone, and barely won. I came back. She had some crazy words to start. She was throwing down 6 and 7 letter words. I was like, what? Getting like 80 points to my like 40 points. Provide a short write-up of explaining the shape and appropriate center and spread for the data. When interpreting the values like the mean, standard deviation, median, IQR, make sure to interpret. So this goes over shape, center, spread right here. Shape, center, spread. Okay. So we don't want to just say the mean is this, the median is this. But this is really great right here because this is review. If we're going to use the mean, what is the appropriate measure of spread? If we use the mean, what is the appropriate measure of spread? If we use the mean, what is the appropriate measure of spread? Anytime we use the mean, we must use the what? Review. Well, no, the median is for skewed data, which is the center. Here, I'll write this down again. You ready? So when we analyze data, we need to first look at the shape. So shape, and we have skewed, or we'll go normal and skewed. And then we have center. Yeah, part 2 of them. So if the data is normal, the center is what? What is the center of the data if the data is normal? If the data looks normal, the center is what? If the data is normal... Oh, I drew that wrong for that. If the data is normal, the center is what? The center of the data is what? If the data is normal, the center of the data is best described by the mean. If the data is skewed, the center of the data is best described by the median. Those are both measures of center right there. And the data is unimolar symmetric, correct? And then if the data is normal, the spread is best described by the standard deviation. And look how they're both over here paired together. And then if the data is skewed, the data is best described as a spread by the IQR. Now, does my data look more normal or does it look more skewed with outliers? And I would need to describe this to somebody. So I'd have to say how my data looks. So does my data look more normal or more skewed with outliers? How does my data look? So we start by describing the shape. Definitely looks more skewed with outliers. So I would say my data looks a lot more skewed with outliers. So I would say that there's some very large observations. There's a right skew to the distribution, or right to the high, left to low, whatever way the monster man's tail goes. So there's definitely some right skew to this data right here, right skew monster man. And so with this, we would say that we would be best describing the center of the data with the median. And so we would go over here. And also the IQR is going to be the spread. So I would say the median, which represents the 50th percentile of students longest hours awake, shows that the 50th percentile of students have a longest hours awake of 28. How do you calculate the IQR from this? What would the IQR be? Mathematically calculate the IQR. You can actually cheat inside of jump and go right here to customize the summary statistics. And under customize, you can actually get it to tell you the interquartile range. And it's just going to be 16 though, because it's calculated by Q3 minus Q1. And so the interquartile range is 16. So that would be the range of the middle 50% for students' longest hours awake is 16. The range for the longest hours awake, the range for the middle 50% of the students' longest hours awake is 16 hours. There's the context right there. So that's got that one. We have interpreted that. We didn't just say it. Next, create a confidence interval. Choose any percent confidence other than 95. So I'm going to do 95, so don't include that. And include a separate screenshot of this interval and interpret it to the reader. So now we go over here and we click this down arrow and we go to confidence interval and select other. 95.999. I can tell you what that is. A 94.999% interval. Don't do this one. Is going to be, it's going to be a upper of 34.026, 34.026, 34.027. Because basically it's what Blake, oh, look, it even rounded it. Blake, it said no. It said no. So don't do this because it's saying 95 right there and the grader's going to get mad at you for that. It did not like our decimals and it tossed it out on us. And so it might have just ran it this way. Jump said, I'm not calculating to that many decimals. But you know what we could have done? We could have done it inside of R right here. R will do it. R will say if you want to do a t.test and you have a vector of data. And so you take your vector of data right here and you say level equals, or conf level equals 0.9449. Oh, look, R will give you the exact right here. And it says with 99, you could probably even go right here and do this. That is why R is more awesome. And it's going to be virtually identical. Have a good Thanksgiving, Kenneth, too. You got it. Great work right there. And so what would we say right here? And make sure to take a separate screenshot of this. Once again, when you take your screenshot, make sure it's not 95 also. When you take your screenshot, make sure you can take extra, but when you go over to Word, you want to go inside of here and put it in. And then if you have extra, which is better to have extra than to not have enough, you want to click picture format and then edit it down a little bit. Make sure you remove out the extra components. And this right here, there you go. And so there you go right there. There it is. That's got it. And so I am 95% confident the true mean longest amount wake for students is contained in the interval 32 to 34. Blake, can you quickly estimate the margin of error of this interval like that? Could you quickly estimate the margin of error? Could you quickly estimate it? It's 1. What if I told you, Blake, I can estimate the standard error of the interval? The standard error is probably about this. How do you think I was able to tell you a very quick estimate of the standard error of the mean? Because the confidence interval is basically what was for the margin of error. I was able to take a quick guess and be like, the standard error is about 0.5. Because the 95% confidence interval is basically, well, so the 95% confidence interval is basically how many standard errors. Since I know what since I know the margin of error for a 95% confidence interval is basically 2 standard errors. Does that make sense? Like the concept behind that? So this is the more advanced stuff. This is the standard error right here. And if it's 95% confidence, this is often close to 2. And so I was like, well, if the margin of error is equal to 1, then we would have to think that this is 0.5 to get 1. Does that make sense conceptually what I did? I was like, well, if the margin of error is 1, then the standard error is times by 2. So 0.5 times 2 is 1 for the margin of error. That is advanced knowledge on this. Like, that's the going above and beyond to understand kind of what's going on with these equations, that this component right here is called the standard error. The t-statistic is going to be found for us by these programs. So we don't have to go in and find the t-statistic. What we do need to know how to do is we need to know how to write sentences like, I am 95% confident that the true mean hours of night, the true mean longest awake for students is contained in the interval. The true mean longest time amount a student has been awake is contained in the interval 32.01417. You can round it to 34.03. With that, I've got 5 minutes and I got a meeting. So great work. Blake, are you feeling a little bit better? Because we just did the t-test. We're at 20 points. We created the interval. We interpreted the interval. Great job, Blake, right here. Hopefully this helps out. That's 20 points of the project. That is the t-test, right? Or the one sample t interval. Everything explained. Make sure you do it for your data. And until then, bye for everyone. Bye. Have a great break if I don't see you tomorrow. Bye.